All right, good afternoon. I'll try not to ramble too much and keep this on track. I wanted to give a quick talk here about visualization compute requirements, considerations, and the dilemma that goes with that. So by show of hands, who would say that the visualization facility they work in most is primarily for big data? Anyone? Okay, Bill. And who would say more immersion simulation? Okay. Anyone besides Bill claim both? Because I know Bill does it all. My point here is we see a lot of commonality between doing data analytics, data visualization, and simulation as well, even though they're kind of separate regimes. Another question. Those of you using a display system, who would say their compute is adjacent to that, like a computer sitting right beside it? A good example would be HMD, but many times larger displays use the same approach. Here's an example that's pretty extreme in my opinion, but the client was set on doing this. It's 24 walls. Each wall has 2 projectors. Each projector stand has a computer that drives those 2 projectors. So all 24 computers are networked together with a master node. What kind of surprised me about this, that they wanted everything adjacent to the display, is it's a military simulator. So there is quite a bit of access control to the site and to the master computer that you need permission to log on to. But otherwise, everything else is very accessible and it's right there next to the display. The cables are 3 to 8 feet long. There's not a whole lot of challenge to connect each screen, each module in this system. So who would say they actually have an air-conditioned room somewhere near their display? Okay, what we often find there is that these systems would be maybe a little more restricted access, maybe a little more IT managed, but still fairly open to anyone with access to the lab. This is a good hybrid example of a lab that uses 3 or 4 HMDs. They also have a CAAV. That CAAV is often used for data presentation. Like in this example, there's windows up for each of the HMD views. But they may also use it for a virtual observation of avatars of the people wearing the HMD. So does that train make sense? So what we have here is 4 walls for the CAAV, plus a master computer that runs the 4 walls, plus at least 4 more computers running 4 HMDs. So that 8 or 9 compute is all in a room right next to the, kind of right behind where the people are wearing HMDs. It's air conditioned, it's controlled, it has decent networking, but anyone in the lab has access to that room. So the last case would be HPC type data center. So who has visualization that actually is served from a data center? Okay. What we find there is it's definitely on the other end of the spectrum for being IT managed. Professional IT department is maintaining the machines, the network, they're pushing updates to the machines, so on as you go along. What I think should be a takeaway here, and I've heard mention of this in a couple of talks, is that, oops. Oh, I'm skipping ahead one, I'm sorry. So if you have an if you have a data center managing your compute, what we often find is those clients many times are doing both data visualization and simulation. And a good example would be a hybrid system like this CAAV2, where there's a windowing controller that controls a scaled window that's like 4 times 4K resolution around this cylinder of flat panel displays. At the same time, there's a cluster of computers that can run a simulation and a master that drives that cluster. So in this case, each vertical column, 3 of those columns would be driven by 1 PC. So there'd be something like 8 or 9 PCs driving the entire system for a simulation. But any data visualization or video or things like that shown on the wall would typically come through a Windows type controller for the system. So where I'm going with all this is a big question we often ask is, where is your IT department involved in this? Over the years, we've had a number of customers who were reluctant to engage their university or their industrial company IT department because they were treating the display as part of a research device. So many of you now using HMDs probably manage those yourself, not necessarily have your IT department take ownership of updating, maintaining, and managing those machines. But as you get into more larger data centers, that becomes more of a consideration. And my advice, I've changed my perspective over the years that you really want to engage your IT group because they can make your life easier in more ways than they can make it difficult. So I would always encourage that approach. So I titled this talk, Visualization, Compute, Considerations, and Dilemma. And I asked my wife how to spell dilemma. And then, and she knew what I was putting together, so she asked me why I was using that word. And we had this debate, and we finally had to go look it up on Webster's. So dilemma may not be the best choice of word here because I'm talking about considerations around the compute, and that word actually, according to Webster's, is undesirable or unpleasant choice. But it does come down to the cost versus performance and complexity is typically what we're working on with compute considerations. And so the question, what is the best solution? There's no easy answer to that because it involves a fair amount of value engineering around the balance of those cost, complexity, and performance. Now, several people, I think Eric just earlier this afternoon mentioned SGI. Who here has worked on SGI computer? Okay, great. So they were the gold standard, and then by the early 2000s, they faded away pretty quickly. But if you had a SGI computer driving a large wall or a cave, it was at least the size of one refrigerator, if not multiple refrigerators. It was an expensive purchase. Oftentimes the purchase of that was started a year or two before the actual final definition of the display system it was going to drive. It was such a major purchase. IT would have been involved. SGI would have done numerous consultations with you about the machine you were buying. That's kind of all gone away. We order graphics cards and motherboards or workstations for the compute now without all of that pre-consulting support that went into picking out that big SGI mainframe that was going to drive the display. So today, typically a client has some idea of what type of display system they're looking for, but we'll start this discussion around how many channels does that display require? And when I say channels, typically today it's HD resolution, 1920 by 1080. But there's variations on what is HD. More and more we're finding channels people are referring to 4K. So a 4K resolution, again, it's not straightforward. It's either UHD or true 4K. But keep in mind, it's 4 times the bandwidth of that previous HD resolution channel. And so with 4K, we still have display products out there that expect 4 inputs. Not many left anymore, but early, especially projectors that displayed 4K required four inputs. Now you can buy flat panels that are a single input 4K resolution. So now we're going to jump the horizon to the next step is 8K. There's not an 8K product available today that takes a single input. Now you can buy an 8K television, but it's internally scaled up to that resolution. So there's not a cable format that'll easily drive one input to that kind of resolution. The products we see typically take 4 inputs to get to that 8K resolution. And those 4 inputs are 4K to start with. So we have quadrupled the bandwidth yet again from the HD standard that many displays are based around. It's a really challenge with bandwidth. And usually what comes out of this discussion is we're trying to identify how many channels are going to drive a display system is an underlying desire to have one PC control the whole thing. So we have a number of CAAV type displays and display walls. They're driven by a single large workstation. That's the desired goal. It keeps the complexity down. It's easy to run a full desktop video or application on that type display. And so typically the answer is yes, but it's a little bit unknown how well it's going to work. Okay, issues with interactivity, frame rate, performance, being impacted by more than one application trying to run on that large of a desktop can be a challenge for a single PC. So as we try and address this issue of how many channels can we keep within a PC, generally we're looking at NVIDIA hardware. And one of the later generation graphics cards would certainly be the performance choice. But generally there's 2 or 3 generations available and a couple different variations on each card. We start to look at specifically how many outputs does that card support. So something like an NVIDIA P5000 graphics card will support 4 DisplayPort outputs. Each of those outputs can provide 8K resolution at 60 Hertz. So you could conceivably drive 4 channels of graphics at 4K resolution. A little bit of caveat that goes with that is the Windows operating system has a pixel limitation. And so NVIDIA graphics also follows a pixel limitation. And can you correct me, is it on the order of 16,000 by 16,000?
Yes.
I think it's on the order of 16,000 pixels in either direction, but it can't be 16,000 pixels square.
I think it just can't exceed like 16,000 in either direction.
Okay.
It's supposed to go up to 32 at some point. That's
it is yet to be realized at 32,000, but I think there's a total number of pixel limitation at 8-bit color depth that it really can't be exactly 16 by 16. So many times when customer says 4K and they want to use multiple ones, we're really talking about UHD resolution, 3840 instead of 4096, because we'll bump up against that pixel limitation. The other thing we have to be careful about is if we're going to put multiple cards in a single PC, that it has to be an oversized motherboard, because these high performance cards are double thick. So they require a full width PCI slot and plenty of space between slots, and hopefully plenty of cooling in that PC chassis if you want to populate it with more than a single card. So again, if you're driving a large display system, and number of channels work out that we can use a motherboard that'll support multiple cards. All right, now you finally got to the point where you can drive that display. Question is, what kind of performance are you going to get out of the card? So I'll run through a quick example here, watching the time. Is the MultiView projector that we're demonstrating is this new product from Digital Projection. It is 4K resolution at 360 hertz refresh rate. So the input to that ultra high frame rate, it does support native full 4K resolution. But some of the drawbacks are it requires 6 inputs. So right away it requires 6 inputs, 4K resolution, 60 hertz. That's a lot of bandwidth. Pretty much pushing the limitation of a single graphics card with what I consider good performance for simulation. So I have a white paper available in the other room that kind of explains more about how this projector works, but the key here is the 6 inputs to drive it. So when we initially set it up and tested it and looked at it, made the mistake of using a lot of test patterns and a lot of simple content and a lot of, Unity type models that were pretty low end. And so we were able to use 2 graphics cards, one card doing left eye, one card doing right eye, and drive that with really decent response. No real concerns there. But as we started to put together a bigger model with more detail and multiple people interacting with it, moving around, we really struggled to keep a frame rate above 30 hertz. And we used to say, maybe, Bill, what would you say, 15 hertz was acceptable?
Yeah, we would live with 12.
Yep, in early CAAV days, but that's long behind us. Typically, I think today people have expectations of a frame rate at least around 30 hertz. And many of the HMDs, especially close to your eye display, will run 60 or 72 hertz.
Interrupt you, Kurt. So CAAVs aren't as susceptible to the frame rate simulator sickness.
Because it's not as close to your...
Well, because you're not, when you turn your head, you don't...
Yeah, so there are a couple of effects going on, but the swimming effect is one that you will definitely see at a low frame rate. And many people will be sensitive to that. So there are a lot of tricks and tweaks to try and improve that frame rate, which will cost you some fidelity in what you're trying to display. Things like anisotropic filtering or anti-aliasing do have settings that you can raise or lower to improve performance. Any literature from NVIDIA would say it's best to let your application control those settings. But if you're struggling for that last little bit of performance, there's a few things you can do there. And we really tried all the ones that are our usual tricks to help with performance and couldn't get a big improvement. So it was simply easier to add a 3rd graphics card. Oops. So ideal choice would have been a P5000 graphics card, all 3 graphics cards identical, each card driving a right eye and left eye for 1 user. Problem was we had a chassis that didn't have enough room in it for a 3rd P5000 graphics card. So once more, this challenge of having a motherboard that has the right slots and enough PCI bus to accept 3 cards, but didn't have the physical space. We dropped down to a P4000 graphics card to fit the space within that chassis. And so the simulation I have running in the other room does run between 57 and 60 frames per second. And that's frames per second per viewer. Each viewer is seeing 60 hertz per eye. So we're really running at 6 times 60 frames per second. That's one thing that makes the visualization seem pretty clear. It's not only high resolution, but it's a high frame rate. It's really approaching the limit of the tracking system. So there is some latency in transport, but a lot of people are not going to be sensitive to it at that point. So a couple quick takeaways here is there certainly is no ideal solution for AR, VR data compute, but there's a lot of commonality that goes between them. I think these similar challenges exist whether it's single user or multi-user, especially when we talk about larger displays. So knowing the number of channels is a great place to start this value engineering around what you can do, but it's really just a start. And certainly one size does not fit all when it comes to a compute solution. So with that, any questions?
I really just need to wait for microphones to respond.
First question is always the opposite side, Bill.
It's good. I'm wondering, you talked about the graphics cards and, you know, some of these systems are now pushing sort of what the graphics card, really even a reasonable expensive one, can do. So is the technology of the graphics cards keeping up, do you think, with what's going to be possible with some of the high resolution graphics that are output by the projectors or by the cameras in the caves? I mean, this is always a marriage that's hard.
Yeah, it's an ecosystem of products. Even if the graphics cards were keeping up with displays, displays are being driven by demand for high resolution in a simple, single display device. So the graphic card makers are of course going to respond to some of that, but that means we need cabling or signal distribution that's also higher bandwidth. And so the wireless Vive is a nice option, but if the next generation Vive is that much higher resolution, there may not be a wireless solution available for a while that can drive it. Same thing, that Quest has all its onboard graphics, so you kind of avoid the bandwidth problem of trying to send high resolution graphics wireless, but at the trade-off for maybe a little lower compute with the onboard compute. So it's always kind of a trade-off at those steps through the system. NVIDIA shares their roadmap and publishes quite a bit about what card is coming up next. And I don't know, I'd say 2 to 3 years easily, there's a new generation, slightly more performant card.
Yeah, supposedly, but then we never know until we have it on hand to test.
I'm looking at Chris here because twice a month or once a month do you have a call with NVIDIA?
Yeah, well, it used to be monthly.
Yeah, generally at least once a month we have a kind of what's new, what's going on call with NVIDIA to try to keep up with with these developments.
Like you said, the motherboard is also an issue too. I mean,
very much so. You could have enough PCI slots, but depending on the make of the motherboard, the bandwidth and the bus and so on may not really support everything you want to do. So once again, we rely on a community of our own clients as well as the people who make the machines for us. And when we tell them we're going to put 24 machines together with 3 cards in each machine and drive a giant display, do you think it'll work? Their guess is as good as ours. But at least they know the specs on what kind of bus pixel rate can be supported, things like that. Clients who use multiple HMDs right now, if they're tethered like a Vive, they're not really friendly to running multiple from a single workstation. And that's due to things other than the graphics in that case. So you still end up having a couple of networked workstations if you're trying to do a multi-participant virtual experience.
Yeah, so my cave runs 4 GPUs, and we run it with 2 CPUs just because we needed, if if you have more than 2 graphics cards, you need more PCI. So we went with 2 CPUs just to get the extra PCI channels.
Yeah.
But we also run ours, we run active 3D, so we're switching left and right on each channel. And if you have more than 2 GPUs, you really have to have a quadro sync just to get all that synchronization channel done.
Yep.
But I suppose because your resolutions, let me know if this is correct, but because your resolutions are so high, you're putting out your left and right eye on separate channels.
That's correct.
And that means that your synchronization requirements are way lower because you don't need a quadro sync to keep all of your graphics cards putting out a gen locked signal, right?
Yes and no. So the projector is still happy to have a gen lock signal because the projector then doesn't have to do anything with those 6 inputs. They're all synchronous as they arrive at the projector, even though they're like a passive right eye, left eye pair. But the other side of that is you do want to use quadro cards instead of GeForce cards, so you can take advantage of sync and not rely on like a software sync that can really hurt your frame rate. So if you're allowing a software swap barrier as you wait for all your channels to finish rendering, and they're not in sync, one channel could be slightly ahead of the previous one in just a 60 hertz timing, and you'll have to wait for it to come around before they all update.
So you're running 3 cards without the quadro sync, and you're just letting the projector figure it out.
In this case, the projector will synchronize them as it receives them, but we have the quadro sync in that machine I'm using as well.
Okay.
So I don't want to trust the projector because I think it'll actually hurt the ultimate frame rate, or it'll drop frames. You might perceive some jitter if frames are being dropped. So I didn't want to risk that. We are still syncing the 3 cards.
Okay.
If I can add a comment, there's another issue that we've run into particularly. So there's another issue that we've run into particularly with multiple CPUs and these larger PC chassis that have different PCI channels for the different GPUs. If you have multiple CPUs, we find that they'll actually split the PCI buses to different cards. And so, for example, if you're running Mosaic, then the PCI bus actually has to transfer information back and forth to the 2 different CPUs that are in the system. So we found increasingly after some of the larger systems, we try to specifically find chassis that would be single CPU, multiple GPU, in order to completely maximize the PCI transfer from the CPUs to the GPUs. And that's something that's bit us with the few installations where we were trying to figure out why our performance was so low with 4 high-end quadro cards, and it ended up being a PCI bandwidth limitation as the chassis was shuffling information between the 2 CPUs. So that's been another one of the gotchas that we've run into.
Yeah, I've observed that too.
Thanks. I'm always excited to ask Mechdyne about what you see in like the next gen of display tech. Have you guys heard of Lightform Labs in San Jose? By chance?
Are they similar to Magic Leap? They're
no, it's a large
light
format, room-mounted volumetric rendering system. Apparently, I haven't seen it. But
okay. I would
raised
like to know
$28
more.
million.
Well, Magic Leap, they're like at 3 billion now. But light field. So 10 years ago, everybody talked about auto stereo display, no need for glasses. Unfortunately, the reality is it's pretty small viewing area to see the benefit of the display. Now it's referred to as light field rendering or light field display, or maybe even holographic, even though that's abusing the term. So there are a number of products developing, and certainly in the HMD area, trying to take advantage of that. I would like to ask you more.
Just read what's on in the news.
So right now we're working with, I think 6 total vendors who can provide direct view LED, and we're seeing 0.9 and 0.7 millimeter pitch, and those are active stereo capable. So that's what I'm seeing as the next thing, but unfortunately the price is way beyond projection. And Eric, certainly way beyond HMD. We're finding more clients will use a combination of HMD and at least a wall display, because if you're going to do a multi-participant experience, why can't one of your experiences be a stereo or mono display on yet another channel that a group can appreciate? You've all experienced trying to hand the HMD back and forth, and some people may be reluctant to put it on. It's always nice to have a stable view of the virtual environment as opposed to a view attached to someone's head who's excited and looking around, because you'll see people look away. They don't want to watch that view, but they'd love to see a stable over the shoulder view of that environment. And we're using all those tools. Instead of driving one more HMD, you just drive a more group friendly display.
So I have a quick question about the number of views, and forgive me because I'm not too hot on some of this hardware that you're talking about. If you've got 3 views, could you technically have two view ones? So could you have the over the shoulder effect?
Oh, yes.
So you could have 2 view ones and 2 view twos and 2 view threes.
Certainly. The glasses are programmed as to trigger for view 1, 2, or 3. And we have multiple glasses now. So I could take a pair without tracking. And as long as you stood near to the tracked headset, you would always have a very comfortable, accurate view. Now you could stand anywhere in the room and see stereo, but it would start to be skewed or less accurate.
Any other questions? All right, I guess I'll wrap it up
All
for
right.
the presentation part of the day. Thank you, Kurt.
Thank you.